right, great. So, as was mentioned, we're doing the biodegradable shotgun shell. We're one of the groups that's presenting tonight, so thank you for being here. Nope, okay. So we're going to talk about our project a little bit. We're going to tell about the motivation behind this, and then the details of how we designed this, and what about testing. And we're also going to cover things like the budget and the timeline that we are supposed to have for this project. So we're going to introduce the team. We're going to start with Jenna. As it was shown in the previous presentation slide by Professor Springman, we're all MET students. And so we all wanted to make sure we had an area we specialized in. So Jenna, she got to do the budget and the timeline, a little bit of the organization. Chris, he was responsible for the design and the 3D design and did the testing. Aaron here, he did the biodegradable aspect of the shotgun shell, making sure that the plastic we're using was indeed biodegradable. And I'm Sam, I'm the team leader. I kind of made sure everybody was organized and, you know, kind of the glue, so to speak. So why this project? Well, we all kind of have this sense where we want things to be more green, and a couple of us are hunters. And so we identify that hunters are probably the main source of income when it comes to habitat restoration and conservation. And as you can see with some of the statistics here, in 2011 we had 13.7 million hunters, and with the license fees and their personal contributions, they brought in about $350 million in revenue. And this revenue goes in towards habitat restoration. And, you know, an example in our area, I don't know if any of you are outdoorsmen, but the area that's Metzger's Marsh used to not be the way it was, and with all the funding by hunters and the state, it is now a nice public area. You can fish there, you can hunt there, and it never used to be that way. So with hunters, these natural resources are becoming more abundant, and we can get these natural resources. However, we know that hunters are maybe not necessarily the cleanest, and unfortunately one of the byproducts with shooting is the casings and the wads are left in the environment, so we wanted to reduce that. So if you've never hunted or don't know much about shotgun, which we're going to talk about the shell itself. So there's an ignition source, and that will ignite the gunpowder, and that will eject the wad and the shot out. So this wad here is the separator between the gunpowder and the shot, and also is good for doing pattern consistency. But the negative aspect is this wad and this casing here are plastic. The wad you will probably usually never find, and most likely you won't find the shell as well, because you are in a wetlands area and it goes right under the water. So these are the two things that are left in the environment that we want to try to reduce. As you can see, here's some examples of pollution. Who knows how long this has been there, but it's been there for a long time. I'm sure we've all experienced going to the lake and seeing pollution, and these might be things that you see. So once again, we're trying to reduce this in the environment. So Aaron can probably talk more about the plastic.
So for our project, the main goal was to develop a shell that was 100% biodegradable. So the plastic that we were choosing to use is PLA, or polylactic acid. And currently shotgun shells are made from the low density polyethylene, or LDPE. So when we were looking at PLA, we wanted to have a short degrading time period. So PLA degrades between 6 months to 2 years, while LDPE takes anywhere from 500 plus years. And one of the other challenges that we're going to have is to actually prove that PLA degrades. So what we did is that we placed our product in a compost pile, and then over a period of time we were weighing it. So when our product first started out, it weighed at 2.91 grams, and then over a course of a few weeks, it degraded or went down to 2.91. So it was a short, I guess, a small amount, so going from 2.2 or 2.92 to 2.91, but it actually shows that our product degrades. And then also our product actually developed a crack too, so it was deforming as well. Now the main issue that we have to also focus on is that the CO2 emissions. So currently LDPE gives off a high CO2 emission, and then PLA, which there's 3 versions of it. You have a PLA5, and then PLA6, and then the newest generation, which is PLA and G. So they all have various different CO2 emissions, but PLA and G is actually negative due to the fact that most people are using it with wind energy. So it actually gets off no emissions. It's taking away from that.
All right, we're going to talk a little bit about the project itself and how we went about doing this. So we initially modeled it, and then we used a 3D printer, and we printed it out as our prototype. We tested it, and then after we got a working model, we wanted to make sure this is something that could be manufactured. Chris can go ahead and talk about the modeling.
So we took our dimensions from a standard shell, and then we used SolidWorks to draw up our 3D model. And we use SolidWorks so that way any one of us can make modifications because we've all had experience using SolidWorks. And then we used a 3D printer to print out our model. And Sam can talk about the 3D printing.
So one of the benefits to having me in the group is I actually own a 3D printer, and so it was nice because we didn't have to reserve time here at school. Anytime we needed to make a change, I could just do it right from home. So if you guys haven't seen any 3D printing, we got a little video. Nothing fancy. It melts plastic and it puts it in layers, and this is what you get. Here. So initially, we had a design that was not as, I won't say pretty, it's not as good. And we made some more modifications because we changed the size of the shell, which we'll talk about later. But as you can see here, it looked better, and we brought a sample to pass around today. So this is more appealing, say, for a customer. You would probably wouldn't want to go to the store and buy something that looks like that. So it was one of the process challenges we had. We redesigned it and we revised it and had a higher resolution. Chris can talk about our testing process.
So the main thing to remember while testing any product that involves a firearm is safety. So we made this test stand out of some 2x4s and plywood. That way we could test our product at a safe distance. When we did our initial testing, the shell broke right at the section where the primer's inserted. So, and the rest of it shattered and flew out of the barrel. So we tried different thicknesses in order to see if it wouldn't break, but all the thicknesses still broke. So then we kind of used that to our advantage because the little pieces that fly out would degrade faster. So that's how we kind of finished our design. And here are some videos of our testing.
Kind of hard to hear, but as you can see, we do have a working product. So it's shot, and anyway, warning. If you are sensitive to the lives of pumpkins, look away now. So as you can see here, is not as consistent. It was a little bit more powder we added. So one of the challenges we had is we wanted to make sure it was more consistent. So we purchased a better scale to weigh out gunpowder in the shot, so we could really compare between the two of a standard shot and our product. Chris can talk about some additional testing we did.
So with the shell shattering, we weren't sure how that was going to affect the accuracy of it. So we conducted some pattern tests in order to prove that our shell was accurate. So as our results show, ours is comparable to that of a standard shell.
And then the next steps of our project would be to make it so a manufacturer can produce this and it can be sold. So instead of 3D printing, we decided to go with injection molding, and then I'm going to talk about how we're planning on to produce it, plus the cost and the budget. So the information that's here on the screen was given to us through Plastic Navigations. They gave us a price for the moldings that we would have, plus the price listed below is for each component per 3,000 units. So altogether, 48 cents for every part that we would be making out of the plastic. And then the additional pricing that you see on the screen right now is pieces or parts of the project that we would have to put in it. So the primer, the powder, and the shot. So with all of that together, it's 38 cents. Our price per shotgun shell with everything in it is 86 cents, as compared to if you were to get like a new factory loaded price is 24 cents. it's still doable. We would like to reduce this cost by in-housing the product instead of what we have going on right now. And then this is our budget that we had. The initial budget that was given to us was $200, so with everything, we only spent $87.17, or $85.17. And then this is the chart, the timeline that we adhere to. Everything that we did was done correctly, and we met our deadlines through everything. So research went through a lot, purchasing, design, presentations, and then the degrading process is still going on until the expo day.
So, in conclusion, we wanted something to reduce our carbon footprint in these natural environments. So we wanted to make sure that our product did degrade, which we were successful in with the degradation testing. We wanted to create a product and test it and make sure it was successful, which we did. And then we wanted to be able to see, hey, can this be mass produced currently? And as Jenna mentioned, it can be mass produced currently, but I think as technologies improve, it can be done more cost effective to a corporation if they wanted to invest in this. So, and then part of our goals is we wanted to overcome all of our challenges, which we felt we have done, and we wanted to hear